In this example, we want to find expressions for v sub x, v sub y, and v sub z using Ohm's law in terms of the currents I sub A, I sub B, I sub C, and the resistance values. First, let's do v sub x. Voltage is equal to resistance times current, but the current needs to be entering the positive voltage terminal in order for Ohm's law to make sense. That means that I need to define a current here, I sub x, such that this assumed positive current is entering this assumed positive voltage terminal. Now v sub x is equal to R1 times I sub x. I sub x and I sub A are in the opposite direction. That means that they differ by a sign, so I sub x is equal to the negative of I sub A. So Vx is equal to R1 times minus I sub A, or v sub x is equal to the negative of R1 I sub A. For v sub y, I sub c is already defined to be entering the positive terminal of v sub y. They already agree with the passive sign convention. I don't need to play any games with those. So v sub y is equal to R3 times I sub c. Now let's take a look at the voltage v sub z. IB is not entering the positive voltage terminal of V sub z, so I need to redefine a current. I'll call it I sub z, which does enter the positive voltage terminal. Now I can use Ohm's law with IZ and R2 to get an expression for V sub z. V sub z is equal to R2 times IZ. IZ is in the opposite direction of I sub b, so I sub b is the negative of IZ. This is R2 times negative IB, and VZ is equal to minus R2 IB.